And then, so this recording is for anyone that I can share this for you later if you want to share with any of your friends or for your future reference. So my name is Anthony Rigi. I'm a 30+ year veteran of the materials industry. And it's been really a pleasure for me to be a part of the design and the construction process with you guys, to sort of take what's in your mind, in your clients' minds, turn it into material, and then get that material into a project where we have a lot of moving dynamics, right? We've got site conditions, we've got people, we have personalities, we have budgets, we have all of these moving targets very often that create some challenges, but I can tell you it's been really a pleasure, and we know where things can go very, very right, because this is a over 50-year product, this Sandfoot wood veneer, which can bond to unique substrates. One of those unique substrates is gypsum. And this relationship with surface materials is now coming up almost into 40 years. So this is a very trusted connection of materials to finished solutions with professional liaisons like we have Therese here as your local market representative, to make sure your ideas become a control sample, become a proper specification, and then Therese and the people like Therese will be sort of your local guides to make sure that the team, which is in my background, is in alignment so that we get everything as it should be. So who are these people? Surface Materials, Jacaranda and Hokusan are the businesses that bring you the Sandfoot. Hokusan is a 100+ year old veneer producer based about 2 hours north of Tokyo. Believe it or not, those are Japanese sandals. So all it takes is, it starts with a passion. A young man stumbles upon a cut stump covered in snow, sees a Tamo ash burl wood graining, starts to make these women's sandals. And how women walk in this, I have no idea. But yeah, that's what they do. And then it turned into Japan's most prestigious wood veneer producer. Okay, so this is an AIA, Health, Safety, Welfare, CEU 1-hour class. And our objectives today is to not only learn about wood, but is to learn about some unique technology that our organization brings to you that are going to open up key doors and solutions to problems that maybe you didn't think were even solvable. And one of those key problems is trying to get beautiful materials into a project within a particular budget. And I think that's probably, if there's any one thing in this conversation, that's probably the one that's going to kind of help folks the most. But, there is also an increasing desire to be focused on our impacts on the environment. And we're starting to equate our footprint, right? We're looking at the embodied carbon of the building. What is our impact in constructing the building, not only the efficiencies of operating the building as well. So, and then of course, through all this process, we're going to teach you about just wood in general, right? What is wood veneers? How do we communicate the visuals, the matches, the slices, the assemblies, because all of this has a crucial impact into what we see once it ends up on the project and how it's assembled into the final installation. So this is the no secret part of wood veneer. It starts with a natural tree, but there's two general categories of veneer suppliers. One is the premium architectural, which is who I represent. And then there is the commodity sector. So if what you're seeing here is a careful coordination of the logs, a very premium select range of logs versus just the side of the mountain, which would be the contrasting commodity sector. And then as we slice it from the log, we reorganize it in exactly the same order as it came off. So in the premium architectural veneer sector, there's a lot of ongoing visual inspection from the harvesting of the tree through all of the production processes and installation processes. The contrast would be the commodity sector would basically just kind of slice a particular species, assemble it, or supply it as you see it, and it'd be very difficult to get even a dozen sheets of veneer that are visually consistent, where it is the norm for us to provide projects in sequences that are well over 100, or even in some cases, even 1,000 sheets of veneer, as I'll show you some of our projects. So after we slice the flitch, and that's that piece of the log that's a very thin veneer slice, we then assemble that per the specification, per your preferences. And all of this is going to have dramatic effect on what that sheet is visually, and how all those sheets will come together visually in the project. So that's the keyword sequencing in these projects, which you don't get again with the commodity sector. So throughout human history, wood is one of those vital, important design materials, but it's also a fuel, it's a resource, it's a building material. We know without wood, humanity would not have been nearly as successful in its growth of population. But we also know that we need to be mindful of how much of the resource we consume and how we take from these forests, so that we are allowing the forest health to replenish itself. So when we look at solid wood versus veneering, you know, if you're starting to take solid wood components, you're going to be consuming at least 50 times more of that particular species. And when the species you want is usually the slow growing species, it's that oak, it's the maple, it's the cherry, where you need 40, 50, 60 years of growth in that tree before it really becomes a good harvestable resource. You don't want to be taking that in a unrespected way. And so, but even from a standpoint, further from a standpoint of consumption, it's also technical. So if you pull a solid wood plank from a species and you have those growth rings like you see here in this upper portion of the log, when it dries, when the humidity goes away out of the plank, you'll have a tendency for that plank to warp. So mill workers who are working with solid wood materials are always being challenged of how you're going to maintain the flatness or the structure of that without fighting all of the growth rings within that solid plank. So as years go on and the ability to get good consistency in veneering improves, we now have this incredible ability to slice to what we do, which is a 0.2 millimeter. All right, now I'm going to get into the market of the typical architectural millwork, which is 0.6, and where we slice in this micro thin realm of 0.2. So that's another difference that's going to be kind of key throughout this presentation. So looking back at the forest, looking back at renewability and trying to minimize environmental impact, there's three different levels of forest. You have your primary forest, which is going to be your national forest, the Amazon, things that have as minimal to even no human inputs or impacts. Then you have your secondary forest, which is going to be maybe state managed, where you timber companies could get leases to pull logs from certain time frames in certain areas, but the forest can then regenerate itself. And then there's the private land, where you've got major organizations usually farming trees, or independent bodies farming trees specifically to utilize the resource. So this term multini is the Japanese sort of equivalent of what I grew up with, which was waste not and want not, right? You just, in Japanese culture, where you've got an island of fixed resources, it's important that they teach to their youth that there's regret in overconsumption. And anyone that knows anything about Japanese culture is that it's incredibly respectful, not only of each other, but also to others and their natural resources. So So that is another reason why this 0.2 millimeter micro thin slicing has sort of come to a reality. But let's get back to the technical reasoning for it. So in the 1970s, if you could afford the best television on the market, it was likely a Sony Trinitron. And because this type of product was most inevitably in the center of the living room, the market demanded a premium veneer on its external skin. Well, if you're old enough, like me, to have seen, the old Zeniths and GEs and Westinghouse TVs, where they were building really this millwork boxes, there was always challenges in millwork, because if the humidity gets too low, you have cracking, you have separation, delamination. If the humidity gets too high, the veneer can push itself off the substrate, and also you'll have bubbling. Also, the heat from the television would also cause issues. So Sony endeavored with our team to find a solution to these problems. And one of the key solutions was get the veneer thin enough so that it did not have the same strength in its push or its pull. Again, it's push in a high humidity, or its pull in a low humidity situation. This is why Architectural Woodworking Institute has, AWI has standards where the humidity window of around 30 to 55% is the happy zone for veneer. Well, I can tell you that here in Florida, it's very difficult to get even to the mid 50s in a house that's even air conditioned. And in some parts of the country, like in the high desert in Colorado, it's very difficult to get over 20%. So it's humidity with natural veneers can be an issue, and this micro thin veneer is part of the solution. Now, there was another industry that benefited well from that, and that's the automobile folks who, obviously, because no one's going to climate control their vehicle full time. And this made micro thin veneer successful in the dashboard market. And there's the term biophilic design, which means that we wish to be connected to nature. We feel better when we're connected to nature. It calms us, improves our focus. It gives us a sense of premium, quality as well. And like you see here at Cathay Pacific Lounge at Heathrow Airport in UK. It's if you're going to pay big money to sit in this lounge, you want to look at some premium natural surfaces, right? So biophilic design is its own class. And when I, hear folks, and I agree that synthetic materials have gotten so good at mimicking nature, that why would we even think of need to go back to natural materials? And my reaction to that is, sure, samples could look incredibly compelling. But when you start to look at a full range of material, you start to look at a wall or a ceiling or anything of any volume, it just, the man-made products tend to go flat. They tend to go, they lose some of that biophilic value. They lose some of that premium characteristic to it. And one of our key strategies is to help you and your client find have a solution to afford this premium surface. So now here is the Alice Tully Hall project, something we're very proud of in Lincoln Center in Manhattan. And those projects coming up on about 18 years old now. And it's the classic architectural millwork, the premium architectural millwork package, meaning you've got the Z-clips with the MDF cores and all of this cool radiuses and fire ratings. And then you have something really quite innovative, which is this red fin, which is backlit. So it's our a technology we helped innovate, which is a translucent backer for the veneer incorporated into this red acrylic sandwich so that this whole wall glows. Now, I do a lot of asking questions when I travel around US, Canada, other markets around the world, asking architectural millworkers, what they're charging, what their costs are, really trying to get a sense of budget numbers, because, you can get a cost point from your rep to say this material costs X. That's great. But what is the material by the time it's assembled with all of its other elements and components when it's on the job site? And the millwork industry is one of those portions that it's very difficult to even guess when you're at the point of design of what the cost points are going to be. So I can only tell you from my experience that the current price for architectural millwork, if it were sequenced, would start around the $80 to $90 per square foot range. That's going to be architectural veneers, sequence, whether it's ours or somebody else's, with the MDF cores, et cetera, with the Z clips and the install. We're going to review that. A project like this, you better start to think if you have $300 to $400 a square foot to include all of the elements before you could really achieve something like this. Now, why does it get to be so expensive? Let's review the components and the processes. So first you have your face veneer. Again, remember, you've got the commodity sector, which is going to be lower price point, and then you have the premium sector. Obviously, there's a price difference just there. Your core materials, a lot of options on this. You've got lightweight, you've got high density, you've got marine grade, you've got fire retardant, you've got hybrid materials. But I can tell you that I would never recommend a plywood substrate when you're doing a lot of wall panels, because plywood is not known for its flatness when you start to do that crossband. Then after you bond the face, you have to put the same thickness or weighted material on the backside so that you have what's called a balanced layup. So that means as expansion contraction is occurring in the space, you have the same tension on the back as you do on the face, and so you maintain flatness to avoid any bowed panels as humidities are moving in the space. Now, after you have the layup, you have to come up with some sort of engineered connection to the substructure. That very often can mean furring, it can mean any sort of different steel substructures. And then you pick from either the old-fashioned French cleat, which oftentimes is just 45 cut MDF, or you go with the good old Z clips, which is a very common solution to hanging architectural panels. By the way, these panels are not light. They weigh anywhere between 3 to 4 pounds per square foot. So what does that mean? It means that you've got to have a substructure system properly engineered with the right amount of fastening points to secure all of these sort of things. And then one of the other points that I want to make before I move on is that we haven't even talked about the finishing, right? So by the time you go from the layup to the dimensioning to the engineering, the shop drawings, the finishing, most mill shops that I've interviewed have said that their internal cost to spray 3 coats of urethane start at around $9 a square foot. And if you have to subcontract it out, you might be paying $13 a square foot just to spray 3 coats of urethane on the panel. And then if you're going to install this panel, the labor alone is around $15 to $25 a square foot for just that. So that's why you can easily get upwards to $100, $125 a square foot, or plus by the time you're trying to achieve something like this. Now, there are alternate solutions. By the way, I asked Therese about this solution because we're switching out the core from MDF to fiberglass. What that allows us to do is by puncturing little holes into the surface of the panel, it allows that sound energy to transfer through and get all confused. That sound energy vibration then gets muffled in that fiberglass. And so now you have a very cost-effective, very lightweight, easy to manage, acoustically absorbent system. Now, here's a project that's almost in completion right now. And this is the South San Francisco Community Center, who, because they have this glass facade and they've got this just 12-foot airspace basically between the millwork and this big glass wall, and the interior of this beautiful facade, radius facade, is a meeting space. So that means this airspace, this 12-foot dimension that goes around the full radius of the space, becomes an absolute echo chamber if you're not thinking about acoustically absorbent surfaces, right? So we're solving the problem of the fire retardancy requirements, we're solving the problem of the acoustics, but we're also solving the problem of the humidity, because they want to open these doors and they want outside air to come in. So that means the humidities may get up to 85%. So this is a solution to the problems, plural, by kerfing this and allowing a flat panel to simply Z-clip to a form structure, whilst maintaining a high NRC value up to 0.95. What does that mean? It means that 95% of the medium frequency sound energy that hits that surface gets muffled and does not reflect back out, is what that NRC means. So there are MDF systems for acoustics, which allow sound energy only to go through them. They tend to be more expensive and more complicated to coordinate. So whether you want the veneer as a ceiling system direct to millwork, or you want it to an acoustic panel, or you want it to direct to drywall, this is one of the cool things that we're bringing to you. Baffles are a great way to deal with acoustics when you're limited on surface area. One of the rules of thumb in acoustics is whatever your square footage of your space is, let's say it's 1,000 square feet space, you want to know that you've got about 1,000 square feet of acoustically absorbent materials. By the way, carpet tile doesn't count. It's not really able to absorb much sound. Okay, so just keep that in mind. You know, clearly a budget route is the drop-in ceiling tiles. You know, they can be effective, but sometimes the project requires something a little bit more premium. So there are systems engineered in that. And going back to millwork, you know, when things start to get complicated, they get expensive very quickly. There are curved cores out there, or you end up with added complexities to bend woods. All of these are going to drive up your costs. So here is the alternative, right? The alternative is, if you don't see it, why do you need it? Okay, question mark. And so here's another beautiful theater. This one happens to be in China. But if you were to achieve a project like this in the United States, I would budget yourself around $30 a square foot with materials and installation. Why is this so much less expensive? Is because there is no MDF core, there's no balancing layer, there's no engineering beyond that of the drywall, which is generally already part of the project, okay? And all we need to do is get that gypsum to a flatness level of a 4 or a 5, and then we can bond this veneer directly to that gypsum substrate in the same manner that we do wall covering, which is why my friend Therese is here, because this partnership has a long history in wall coverings. So I just want to be clear that we're a veneer entity. They were teaching on veneer, and we could do all the things that typical veneer guys do, but we do have this opportunity in this microthin veneer in bonding it directly to this gypsum substrate, like you see again in this project. So this is kind of our dime a dozen, type of install. Because these corporate spaces, very often they're leased, they're somewhat temporary, in the sense that maybe they got 5 or 10 or 15 years of life in them, right? So you can't allocate, $200 a square foot to architectural millwork when you've got that sort of kind of expected life in a space. So building this out of gypsum, within 8 weeks, we can supply the veneer in the match in the slicing per your specification. About 8 weeks, it's on your doorstep, ready to install. So it kind of fits really well in the timing requirements. And you see here a flat cut book matched walnut. And notice that sequencing. And you'll also notice you don't see any seam. When you're working with MDF or plywood, you always need to be mindful of the movement, the expansion contraction of that panel. So that means some sort of reveal, some sort of detail to allow that climatic movement. Because the gypsum doesn't move hardly at all, and really the veneer is moving so little as well, you can do this overlap and double cut and have this seamless appearance on this, even though that there is a seam every 3 feet vertically on this particular installation. So we're giving you a lot of options, and again, we're happy to always go the old school route. Here you've got the Londoner Hotel in London, a Yabu Pushelberg project, and Yabu Pushelberg just comes to our team because the sequencing can be so substantial. Unfortunately, I forgot to mention to you that Alice Tully Hall project, that was all cut from one tree. That was over 2,000 sheets that were all cut from one Moabi log, 4x8, by the way. So that's why that project looks so incredibly consistent. So when you slice micro thin, you triple the yield that you get in that log, and it means you can also afford better logs. You can afford that more expensive, longer, that older log that's got more dimension on it. Okay, so here's the different cuts. The flat cut, which is the log cut in half, and you are now slicing in a very angular attack to the growth ring, okay? And now the log has, of course, you've got the bark, then there's a sapwood, which is a very light colored outer ring there. That's usually trimmed out, but I'm starting to see more sapwood. I'll show you some pictures of including the sap in your specification or in your project. And then we get to the heartwood, which is darker, it's harder. And that's what you're seeing here is all flat cut walnut in a book match assembly. And you see that book match is that mirror image, okay? Then there's the quarter cut. The quarter cut means the log is cut into quarters, but now that blade is going very perpendicular to the growth ring. So the difference is, because of the angle attack of the blade, you get cathedraling from the growth rings and the medullary rays that emanate from the pith, which is the beginning growth of that tree, versus the quartered log, which is now going very perpendicular to that growth ring, and you get this very linear appearance on the flitch. But note, the flitch also is not as wide. The rift cut is effectively like the quarter cut, as we just showed you, but specific for the species of oak. So you won't see rift cut on other species beyond oak. It just is the growth rings, the way the growth rings are on the species of oak. It means that this radius that the blade is able to achieve with that growth ring is such that it just visually the right appearance. Okay. Rotary cut is what you see in your plywoods, because this is the lowest cost way to slice an architectural wood veneer or slice a log, period. And so your plywoods are just cross bands of this rotary cut, where you can get whatever dimension you wish from this log as you peel it. This rotary cut is also what is the raw material when we make a recon, or you can call this a man-made log, so to say, right? But we call it a recon block because we build it in, as you see it, a rectangular block, which then is just layers of veneer with maybe some folds and some stains. And these veneers are more often than not going to be fast-growing farmed trees, eucalyptus, poplar, obeche, just kind of low cost, fast growing trees. For example, a eucalyptus tree could be planted from seed and in year 8 have a harvestable resource. In fact, if you cut that eucalyptus at the stump, 6 years later, you can get a second harvest off of eucalyptus. By the way, eucalyptus, even as a natural species, I got to tell you, is quite beautiful. So there are species that are really, really good sustainability choices. Check with your rep and us as if you want to kind of focus on those species rather than others that are less renewable or less abundant. So recons are also a good choice when you're looking for a high level of ongoing consistency, because this is ultimately a layer cake that we get to repeat over and over again. So that if you've got a hospital chain or an office standard that you're looking to kind of keep always the same, I think a Recon's an excellent choice. Or I would always counsel some level of stain in a natural, like we did here for AC Marriott's. This is, you've got your stained walnut, because the stain is the best way to stabilize the coloration in the UV in these types of projects. Okay, so again, you see the book match, the mirror image there. And I see this being specified, and in some cases, I think over-specified, because I think there's some mentality that people think, well, if I want it, if it's book matched, then that means I get a level of consistency. But I just want you to know that book matching in certain species, particularly highly reflective species, like you see here in this anagray, or you see here in this maple. But we'll see it also in oak, and we'll see it in cherry. All sorts of species where you get this barber pulling, which is a light reflectance, right? So anytime you change the direction on something, and this is true in synthetic materials as well, you potentially change the way the light reflectance will hit it, and it will change its appearance. Now, we can have a lot of fun with that too, right? Like in this particular project we did, gosh, about 20 years ago. This is just simply achieved by changing the direction of the anagray. And we can make this as a pre-engineered or pre-built program. For example, this sheet on the left could be sheet 1, sheet 2, sheet 3, sheet 4, sheet 5, and that could all be sequenced by our factory, so that all the installer needs to do is come in and follow, connect the dots, right, and do the install. But look at how beautiful that is when you change your direction. I'll go back and forth again. So, I mean, just look at that, and then boom, change the direction, look straight on, and just absolutely stunning project. So again, we need to understand what is in your imagination of your visual at the time that we're writing the specification, because it's just so difficult to look at a control sample and imagine what that's going to be by the time it ends up on the project. And it's also leaving too many variables open to interpretation by the installer, which can really cause some strife down the line. So these are the things that we want to really communicate openly early, so that we get your spec right. We know exactly where you're at, and we're happy to communicate all of the options with you, because very often I find that we're switching the original book match specification for the slip match, like you see here, meaning they just slide next to each other and everything is now in the same direction. Or you don't want it to look so consistent. You want it to be a little bit variable, but you want it to be variable in a controlled way. And that's what we can do with you in the random match. And in some of these situations, we're mixing quarter cut with flat cut. Sometimes we change the direction. Sometimes we integrate multiple logs, just to really give you the variables that you want to see, particularly in that species or not. Again, it's a controlled situation. End matching is like the book match, but for the ends. So it's the mirror imaging of that. And if you wish, and you see that a lot in stones, it can be really quite beautiful when you see it in stones, and in wood, it can also be quite amazing. In this particular situation, I always want to be mindful of what is the tonality difference when we turn a sheet upside down effectively, and we have to build these sheets so that the mirror imaging is happening on sheet 1 to sheet 2. So this gets into some of the blueprint matching. Yeah, we still call it blueprints, so that we can really understand when we're building the veneer sheets in the factory, that they are as they should be when they align on the project. And so we'll work with you and kind of spell this out for you as we communicate. And by the way, this is kind of, these types of things are normal for us. They're not a crazy cost increase or out of the norm. We are more often than not really building a veneer sheet specific to a project. But we can have a lot of fun with this stuff depending on how much is in your budget. Certainly creating inlays or block planking. And another cool thing that we'll do is we'll take timbers, and instead of a recon block that's using veneer sheets, we'll build it with timbers and then slice it again, so that it makes a project like this very simple, as a wall covering installer would install, rather than trying to get all these complexities of fire rated plywoods and timbers, and how are you going to glue it? Are you going to toenail it? Are you going to finish it on site? Things like this can be really complicated when you're talking to a carpenter, for example. So getting timbers to ceilings, other than the typical tongue and groove, if you're going to a gypsum wall, bonding that veneer directly to that gypsum can be very cost effective. And as you can see there, a project like this, if you ask me what the budget number would be, I would say between $15 to $20 installed per square foot would be about a fair number. That would be all your materials, labor, not the cost of the drywall. So remember, we're just giving you options here. So whether you want to go acoustic, you want to go directly to gyp, you want to do some of this as architectural millwork, all of these are, and you may have a project which has a blend of them all, right? And that's again why you need your friendly local liaison like Therese here. So Echo Condo, another project we did in Miami where we did recon. This is a recon rosewood. This is called a pleasing end match, where we took the recon and we turned it upside down and created this this appearance, so that it just really gives it the just the consistent look on this 13-foot high wall. And by the way, these sheets are measured. It's the biggest sheet we produce, 4 foot wide by 13 foot tall. There were 1,600 sheets of this on one installation, and I'm friendly with the installer. He did it all by himself. Now, it did take him about 4 or 5 months to do the project, but literally one person installed all 1,600 sheets. And the thing I love about Lloyd is his work is flawless. That project is perfect. So here's how it all comes together. First, we have our primer. This is an important part of the science, the primer and the clay adhesive. If you go with whatever you think works, this is where I have failures. We have a blend of products we know work. We've tested them to multiple substrates in different conditions. So I'm always happy to speak with installers and confirm, hey, what have you used? What do you buy normally? Let's make sure that the product that you like to work with is something that we have tested. Of course, all this is also listed in our installation instructions, but there are sometimes even elements we can add beyond that, of which is just listed in installation instructions. Now, what is clay adhesive? Well, it's exactly that. It is Georgia clay mixed with water, salt, and a bit of chemistry. The cool thing about clay is when you get it in the back of the sheet of the veneer becomes flexible. It's that moisture is absorbing into the veneer, and it actually becomes easier to work with the material. So, notice this walnut, and this was, of course, in the years of the walnut 5 or 6 years ago. Now we're in the time of the rift white oak, or flat cut white oak. So just interesting how the trends sort of shift. But and I think we're on the precipice of burl, by the way. It's kind of like the next thing. But so this is Oscar. Oscar is installing the Dalmar Hotel in Fort Lauderdale, not far from where I am here now. And Oscar and his helper are able to install an entire floor of these doorway kind of soffit inset areas in a day. And we're meeting the fire requirements. It's always going to be a Class A fire. All we need is that wall is going to be a Class 4 or ideally a Class 5. I got to tell you, in this project, I saw a lot of 3s. So I get that question a lot. What if the substrate isn't as flat as a 4? It means you're going to see those impurities, but sometimes the owners, they squeeze the contractors and they really are trying to get as much as they can for as little number. And when you start to do that, you can expect to start to see some sacrificing in the quality of the workmanship. But
Can I ask a question?
yes, please.
Are you priming the wall with, when you said primer and the clay adhesive, is the primer going on the wood veneer sheet, or is it like, are you also like priming the chip before you apply?
Good question, Jennifer. The primer only goes to the wall we're bonding to. The clay only goes to the veneer, and then they mate. There are some situations where you would prime the wall, and I would say priming is almost an absolute. Like, you really got to make sure you've got a good primed wall, unless it's a raw wall of gypsum. But if you've got a mud float, which you should,
Yeah, right, at a level 5, yeah.
or you have a paint of some type that was from before, you absolutely need to get a high quality primer. And I showed you the Roman product, but Guards is a good one. There's Zinsser. There's a bunch of brands that we've tested to multiple substrates and gotten good results. So, but there's wall covering primers that truly dig into the substrate, provide the right surface for the clay to connect into, and so in the adhesive term, it's called cross-linking. When the clay has still viscosity to it, it's still got moisture to it, it's going to start to dry and cross-link and grab onto that primed surface, and that primer is digging even deeper into that substrate. And when we have that bond right, we don't have any claims. It's that simple. I mean, we just got to get it right.
I'm just even watching in the video. No, I definitely see they're doing really great wall prep, but like, that's definitely, even with that exposure of the paper there, not that it can't be a level 5, but it's not like a fully primed wall necessarily. I know, like, ideal install, but okay, that's great. Thank you. Sorry to interrupt.
Yeah, no, my pleasure. Good questions. And there are clear primers, there are tintable primers, there's a lot of options again. But this is one of those things too, where, and I'll consult with particular projects, especially if you've got hard to access areas, high elevations, things that you needed to get scaffolding or scissor lifts or things like that. I tell folks, you know what, do 2 coats of primer, one in one direction and the second one in a perpendicular direction. That gives us really the best chance for excellent bonds along that surface area, because it's just too inexpensive and too easy to do it. Just give you that insurance policy, and then once you get the clay in the back of the sheet and then it sticks to that prime surface, it's we've got projects that are well over 35-40 years in existence, because the thing about clay is, once it's hard, and it doesn't degrade, which is why they love clay for porcelain. And clay's got a lot of cool, and pottery, and it's just one of those forever raw materials that if it's used in the right way. So I also tell folks, make sure you install a few sheets and get everybody's thumbs up before you keep going. Mistakes happen, right? Miscommunication, misunderstanding, any of those sort of things. There's a lot of human beings involved in this. So just get 3 sheets. Everybody put their agreements on and how it's going to be installed. Make sure you got the right quality tradesperson. I've had tradespeople fired after they've shown what they can do with only 3 sheets. And I do like when we have some inputs with the installer, and in some cases can actually recommend some folks as well. It's always a good thing. I am working towards a specifiable certified installation program, but we will always be eager to train installers that are good in the skill set of wall covering, but maybe never installed wood veneer before. So we will always be happy to engage new trades, new installers. We want as many people comfortable with this as possible. But if you can install wall covering well, you can install this well. I must admit, I find that the folks that do the residential jobs, the premium residential jobs, to have just a more detailed care than some of the guys that just really run and gun with a lot of the contract stuff. But yeah, razor blade, damp rag, he's able to overlap those seams and do the double cuts, which you saw over that doorway. You know, he just kind of overlaps them, does his razor blade, and then pulls out the waste. So this clay is sticky, but it doesn't get everywhere. But you do want to make sure you get all the glue residue off the wall, because if it starts to dry in that wall, because you got a lot of glue moving around, it becomes more difficult to clean off later. So cool. Let me keep moving on. This is the finished project, and it's used often in the common areas. I do like what they did here with these bases by keeping these bases. You know, imagine all that luggage that's going to be moving around in this corridor, and that base that's sort of set off at least an inch off the wall is going to be a great way to keep that luggage off of the wall as much as possible. Now, if it does scratch, the same folks that repair furniture, because the furniture delivery guys did some damage, would be the same guys with the same skills and the same materials that would resolve scratches or gouges in our material. So these projects are commonplace for us, but because it's natural veneer, premium natural veneer, it lends itself to be suitable for the premium high-end brands, but also very affordable for the more budget brands, as we did not that long ago, a Hilton Garden Inn. Now, is it everywhere? No, it's just in some key, feature areas. But, with premium veneer, a little bit can go a long way. And for those of you who are struggling to manage the condo commandos and give them a design package that can retrofit relatively easily on budget without creating a lot of construction and timing and so forth, this is a perfect product for that as well. Now, sometimes your substrate is different. In this case, we're using contact cement to a steel fire door. And contact cement is one of those materials that a lot of people can use. You can spray it, you can roll it, and I myself, we're starting to work with a peel and stick adhesive, so the veneer already has the glue on it, which even makes it potentially even easier to do in the field. But the basic concept of contact is you spray out on both surfaces. You wait for them to flash off. In other words, you just let the moisture come out of the adhesive. You put a slip sheet between there, and you position the material, and then you pull that slip sheet out. So it's a pretty basic and simple concept there. All right. So, and one of the other cool things about the 0.2 millimeter is that the veneer thinness is such that it won't crack when you go to fold it. So a little bit of moisture on the surface of the veneer, which can soften it, means you can wrap it around a hard 90-degree angle. And then this starts to kind of resemble more an arts and crafts project than it does a millwork type situation. So imagine, you got your wall covering trade doing your directed jip, and then you have some doors that you want to be in sequence. Just pull those sheets aside, keep them in sequence. And if the wall covering trade isn't comfortable with working with contact cement, anyone with carpentry skills will no doubt have a comfort level with it. This is actually one of the Surfaces projects. This is Emory University. It's a medical training complex in Atlanta. And cool situation here, because in this project, the architectural millwork budget was being almost threatened to be pulled out completely because it just was not in budget. And by bonding the veneer directly to the gypsum in this back wall and these corridors, and by bonding the veneer directly to the fire doors, it was able to save over $1 million on just this project. So just keep in mind that there's potentially substantial savings here, where even if a project has been previously specified millwork, and you're looking for some way to squeeze in that wood and still keep the dollars and cents making sense, then this is a proven solution. Now, because it folds so well, I also can contact cement or use the peel and stick adhesive and wrap it around these corner guards. In fact, I was just doing it the other day. It's just so easy and actually kind of fun just to bond these things. And what's cool about that is if you do these corner guards using the same veneer, I mean, they almost disappear, right? And you make some extra ones so that if that corner is beat up and damaged with a clear silicone adhesive, you can pop that off and pop in another one down the line. So these are great, easy solutions to get perfectly matching corner guards. But the veneer can fold around those outside corners, and these burls, I think we're coming back into a burl phase, and we can still incorporate reveals, fry reglet reveals like you see there with some lighting. This opens up design possibilities because you're not at the mercy of the 4x8 or the 4x10 anymore. And there are situations when you can bond to MDF in the field. Definitely give me a call, or give your rep a call, because I'm gonna give you some caveats and issues and things to be careful about in that. Notice this end match on that flat cut teak. And by the way, this is in Toronto. This saved the project over 60% from its original millwork budget just by bonding the veneer direct in the field. So a lot of potential savings, a lot of cool opportunities. There are different ways to deal with outside corners, inside corners. This one is a paintable plastic. Really does a nice job of getting that very minimal detail there. And here's a medical complex. Do a lot of these actually, just to give you that biophilic. These are stressful environments. You walk into a space for some sort of treatment, you don't want to be there. So I know specifiers are doing their very best, and the owners, to make these as warm and as comfortable a place as possible, as are hotels. I know I don't want to be in a hotel all the time. So, getting some of these biophilic natural materials, and because it's directed gyp, it even affordable for these Hilton Garden Inns. The microperfing and acoustic is another really cool value opportunity. It's hard to see, but that's all microperfed on that column enclosure there. So there are just so many cool solutions to decorating your parts and pieces of the building, allowing you the freedom of radiuses, allowing you the freedom of digital prints, like we did here in Manhattan. This is a recent project using the acoustic. So that's microperfed, acoustic, digitally printed, and custom stained in ceruse. This is like the full Monty here. But the end result is just cool piece of art design but still functional with the acoustic absorption. And believe it or not, incredibly affordable for what it is. So it's good solutions there. We do still offer you the freedoms of inlays. But remember, there's not a collection. When you're working with natural veneers, where, yes, we always have oak and walnut and cherry and maple, but there's 100 different species that you can consider and think about. So I tell folks, open yourself up to eucalyptus or paldeo or, some Japanese sen or some other, spotted gum, which is part of the eucalyptus range. Very sustainable species too, very, very beautiful. And then when we stain them and we slice them in the way you wish and we assemble them in the way you wish, they can be amazing. I'm almost done here, guys. So side note, the veneer, particularly on the species, this is Douglas fir. Now, Douglas fir can change quite a bit. This is it, how it would look fresh from the factory. This is, it's sitting on a sheet that's been sitting in a box for about 3 to 4 years with almost no sunlight. And then you have a sample here that's been exposed to full sunlight for about 3 to 4 years. So if that's the sample you signed off on with your client, and now your sample looks like this, let's kind of have that conversation early of, are we going to stain this Douglas fir to this color? Or are you okay with it looking like this now and 3 to 4 years looking at like this? In the case of San Francisco, yes, they are, but some clients have issue with that. So let's just keep all the dialogue, forthright. So there's just further ranges of knotted, planked, those timbers, so you can get those end planks there again. Translucents for glass. These are the guys that made the gray hairs that made the Alice Tully Hall red fin work. You got a veneer expert here, Tom, and you got Jeff here, a glass expert and acrylics. And we love to figure out how to make our products do different things and open up into new market segments. And once we learn how to do it, we love sharing it with the next folks looking to do the next project. Like Paul Logan or Logan Paul, I don't know, young people would know who he is. Or here's a really cool project we did at George Mason University with a rear projection, super cool project. And it just, again, communicate on your goals and we'll help you achieve them properly. This is when you're spending too much on your latte. Here's Starbucks in China, all to metal ceiling tiles, and they loved it so much they did it again in Tokyo. And we do change the glue and we change the substrate based on the climate conditions, right? So in this case, you've got an aluminum beam. So because these humidities are incredibly difficult to manage in these types of conditions. So we will definitely guide you to different substrates in different situations. So CITES is Convention on International Trade of Endangered Species. So for example, if I promoted you Tamo ash burl 6 years ago, I can't sell it to you now because red flags go up among legitimate governments and legitimate businesses to say, we are over harvesting this particular species based on its particular growth rate. So this is nature's defense. This is far more important, I think, than any other third-party certification. And it's probably something that very few or any of you have even heard of before. So legitimate businesses, legitimate governments follow this sort of stuff cautiously and carefully. Okay. So just keep that in mind. These are the typical projects we do. Again, all to direct to JIP. This was in Los Angeles. Some beautiful slip matching there and incorporating more and more sapwood, which I think is a beautiful contrast. And I'm going to end here in the next couple of slides. This is why sequence is important. When you go to the commodity sector of the market and you're looking for just flat cut walnut and you're not paying attention to how it was sliced, how it was assembled, how it all goes together, you get an unknown quilt work. And this is how an architect gets egg on their face, not realizing how important that word is in their specification and how it impacts the cost of the final project. So ending you here with a surface project, this really cool MCC University. It's in Rochester, New York, all direct to JIP. It kept everything on budget, everything on time, and was an award-winning design simply by just changing the means and methods with a material that allowed it to bond to that gypsum substrate and keep everything in cost alignment and in time alignment. So guys, that's my presentation. I thank you. I'm going to open up the floor. There's only 6 of you here on this, so feel free to go ahead and ask questions.
Have you had any successful applications for like a knife edge on a cove ceiling?
A knife edge on a,
Cove ceiling?
a cove ceiling.
Yeah. I can share maybe at post meeting, I can share a detail with you. I'm looking for one opportunity.
Yeah,
Yeah.
I'm not completely clear what you mean by cove sealing, but yeah, we can fold the veneer, but there are different strategies I would counsel, based on the ceilings, especially when you want to kind of have some dimension. Because the only way the folding works well is if the seam, that joint, that angle is really straight. So I've got some installers that have given me some different feedback on strategies and how to deal with that. And so I could review your options once I see exactly what you're dealing with.
Okay.
And I don't mind staying on this meeting as folks sign off if you want to go ahead and share what you've got.
Yeah, unfortunately, I'm back to back on things
No
today,
problem.
but I definitely can email you and I'd love to set up a time.
That sounds great. Thanks, Jennifer.
Thank you.
Great. Well, thank you guys. And thank you, Therese, for getting folks here to listen to me for the past hour.
Thank you, Anthony. It's always very informative.
No, my pleasure. I'm gonna stop this recording, and I'll